Right. So since we have, as we have talked about the fixed length subnet masking, let's talk about the variable length subnet masking. So the problem with the fixed length subnet masking is that we are assigning a fixed number of nodes to a subnet, regardless its requirement. For example, in our problem, every subnet needs to have 35 nodes. But how many number of nodes we are assigning or reserving for each subnet? 2 raised to the power 5 minus 2, that are 30. So this means we are wasting the nodes because it does not cater the variable set of requirements of each subnets, because each subnet using fixed length subnet mask will be having a fixed number of nodes, right? So in order to address this problem, we have variable length subnet mask, VLSM. So the variable length subnet masking is a process where we subnet a subnet, where a subnet is further subdivided into more subnets, and we'll keep doing this process to cater the need of the different subnets. For example, think of it as a think of it as a round of subnetting, right? So this is the first address this is the network address uh, that we got from the ISP, 10.0.0.08, and this prefix here represents that 8 bits are representing the network portion. And what I have done in the first round of networking, I have um, I have borrowed the uh, the second complete octet. I have borrowed this octet, right? So this means how many subnets I'll be creating? Yes, you're right, 256 subnets. And now I'll take one subnet that is 10.1.0.0. Now this slash 16 here represents, prefix 16 here represents that. Now, uh, now 16 bits are representing the network portion here. And I will again subnet it. Now, if I borrow again the complete third octet, right? So what I've done is I've borrowed this third octet for subnetting. I'll be creating another 256 subnets, right? And again, I can take then another subnet and create 256 more subnets, and then so on and so forth. So let's see how it is done. So what we have to do is that we have to find the largest segment, the segment which needs the largest number of host addresses. So we will try to arrange the requirement in such a manner that we'll be dealing with the largest number of segment first. So we first do the subnetting to fulfill the requirement of the largest segment, and we will assign the appropriate subnet mask to the largest segment, and then we'll take the next largest segment in this sequence, and then again we'll assign the subnet mask, and then we'll keep on repeating this step until we are done with the all segment requirements. And let's try to understand this with the help of an example that how it is done. So for example, that we have a class C address, and this is the requirement that we have to meet, right? For example, at ComScience University, for computer science department, I need to have 74 nodes. In electrical engineering, I need to have 52 nodes. In physics, I need to assign addresses to 28 nodes, and then I have a WAN link to complete this topology. I need 2 addresses here. Then there is a subnet for the WAN link 2, where I again need 2 addresses for 2 router interfaces. Then I have a WAN link 3, where again I need 2 addresses for 2 router interfaces. So how many number of subnets are there? 6, right? And what is the maximum number of host requirement for computer science? 74. So if I ask you to do it using fixed length subnet masking, can you do it? Can you do it with fixed length subnet mask? You cannot. We can have a quick calculation. How many subnets are required? 6. How many number of bits needs to be borrowed? 3. Right? So okay, we can create 6 subnet. This is class C address. And how many number of bits are there for the host portion? 5. So 2 raised to power 5 minus 2. 30. So this means at maximum, each of these 6 subnets using fixed length subnet masking can only have 30 nodes. But here in computer science, we want to have 70 addresses for the 74 machines. So see how it can be done using a variable length subnet mask but the first step in order to do is to arrange the requirement into in this descending order. Okay, so where the segment requiring the largest number of nodes are first, then second, and then so on and so forth, right? So what we'll do, so this is the class C address that we're given with. So this is the address that we are given by the ISP, 192, just assuming 192.168 .1.0. Okay, and we know that here 24 bits are for the host portion by default. 24 bits are for the network portion by default, right? And 1 octet is for the host portion. Okay, so the larger segment, computer science needs how many number of nodes? Yes, you're right, 74. So what I'll do is I'll borrow 1 bit here, right? So borrowing 1 bit means now how many number of bits here in VLSM representing the network portion? Yes, 25. Okay. Okay. So what subnets I can come across? Yes. So in last octet, either the bit is on or off. If it is off, the address is 192.168.1.0. So this is something that we are given. We cannot change it. Here I borrowed 1 bit. Its value is 0. This is one subnet. And if its value is 1, because so this is the network portion. This socket represents in class C network part. Network part cannot change it. Its values are given 192.168.1. And here what I'm doing, I'm borrowing this bit from here. Its value can either be 0 or 1. If its value is 0, so I will have this address 192.168.1.0. And if its value is 1, so this means I'll have, right, this value. So there are two possible subnets, 192.168.1.0 or 192.168.1.128, right? And what would be what would be the subnet mask, by the way? What would be the subnet mask here? Yes, you're right. So 255.255.255 is by default. We cannot change it, right? And what we have done is we have borrowed 1 bit, so the subnet mask here would be 255.255.255.128, right? So if I talk about this subnet, so the address of the first node would be 192.168.1.1, and it will go up to .126. Why? Because 127 will be the broadcast address. Okay, and if I take the other subnet where the address is 192.168.1.128, so if I on 1 bit here in the host portion, its value would be the first address value would be 192.168.1. Yes, you're right. 1.129, and the last usable address would be 192.168.1.254. And if I turn all the bits on, you know that it would be the broadcast address. Okay, so if I summarize it, the requirement of the first segment, we need 94 node addresses, and the prefix is 25 here. Why? Because now 25 bits are representing the network portion, and this is the subnet mask that we have just calculated. This is by default. Represents the network portion. Represents the network portion. All bits are 1, and 1 bit, since one bit is borrowed from the last octet, this value is 128, and the network ID is 192.168.1.0, and the first host is 1.1, and it goes up to 1.126, and this is the broadcast ID. Okay, right? So this fulfills the requirement of the larger segment. So what was the requirement of the next segment? EE, right? So in EE, we needed how many number of host addresses? 52. So what I do is I again borrow another bit from the host portion for subnetting, right? So this means This was by default, network part, network part, network part. And what I've done is from the last octet representing the host portion is that I have borrowed another bit. So what would be the subnet mask for the second segment? So 255.255.255.128 plus 64. That's right. Dot 192 would be the subnet mask. So I have borrowed 2 bits, so I'll take the 4 possible combinations where all these bits are 0, so value is 0. This means the address is, I'm talking about this subnet. And if I on this bit, the 64 bit, and this bit is off, this bit is off, and this is on, its value is 64. I add 64 into 64, I'll get the subnet. I'll add 64 into 128, I'll get the next subnet. So there are 4 subnets here. Okay. And the first subnet, and how many bits can be, how many node addresses can be against each subnet? This depends how many number of bits are there in the host portion. How many number of bits are there in the host portion? If 2 bits are borrowed, yes, 6. So this means 2 raised to power 6, 64. Okay. So here the first address is 1 and the second address is 1 means dot 192.168.1.1, and then it goes up to 192.168.1.62 and 63 is the broadcast address. Same is the case with the subnet 2. Subnet 2 starts with 64 and 65 is the first node address and goes up to 126, and then we have the broadcast address, and then we have the other subnet ranges. So what do you think? Should I assign doubly the node addresses from the first subnet, or can I assign the first subnet to doubly department? No, I cannot. I cannot assign this subnet. Why? Because this subnet is assigned to the CS, right? So in this range, computer science has node addresses. Can I assign this subnet? No, I cannot. Right? Again, from this range, we have addresses to, we have a reserved addresses, we have node addresses of computer science. I cannot assign these 2 addresses. Yes, I can assign this third subnet to doubly. How many number of nodes are there? There can be 64. What is the requirement of doubly? 52 nodes, right? So I'll assign this third subnet to electrical engineering department, right? So if I again look at the summary, what was the requirement of doubly? 52 nodes. What is the how many number of bits are representing the network part used for masking? 26, right? So this is by default network portion. All the bits are 1. 255.255.255. 2 bits are borrowed, right? Bit number 128 and bit number 64. So the subnet mask for electrical engineering department is 255.255.255.192, and 191 is the broadcast address here. Okay. And let's talk about the third segment, which requires physics, and it requires how many number of nodes? 28. I borrow another bit from here. So what would be these subnet mask now? So 255.255 is by default, and now I've borrowed 3 bits. Bit number 128, 64, and 32. So this means the subnet mask would be, yes, 224. So 255.255.255.224 would be the subnet mask for physics department. So I have borrowed how many number of bits here? 3. So 8 subnets there. The first subnet ID is 0, right? And we can have how many number of hosts against each subnet? So how many number of bits are there in the host portion? If 3 bits are borrowed, 2 raised to power 5 is 32. Okay. Right. So the first subnet is 192. The first host address is 192.168.1.1, and it goes up to 1.30, and 31 would be the broadcast address. So similarly, the second starts from 32, 33, and it goes up to 62, and then so on and so forth. So can I assign this first subnet to physics? No, I cannot, because here I have assigned nodes to CS. Can I assign second? No, I cannot. Right? The addresses are assigned to CS. Can I assign nodes from this subnet? I cannot, because the nodes are assigned to CS. I cannot, right? So can I assign nodes from here? No, I cannot. From here, the nodes are assigned to EE. Can I assign from here? I cannot, because nodes are given to EE, right? But I can use this subnet, right, which is for, so I can assign this to physics, where the requirement is to have the node addresses for 28 nodes, and I can easily assign addresses to 32 nodes. Okay. So if I look at the summary here, the requirement was to have 28 node addresses. The number of bits that are representing the network part are 27. Why? Because this is by default 24 bits and then 3 bits. So this means in total 27 bits are representing the network part. So the subnet mask is 255.255.255.128 plus 64 plus 32 means these 3 bits, since these 3 bits are borrowed, dot 224. And the first address is 1.93 and goes up to 223 and 222, and 223 is the subnet. 223 is the broadcast ID.